Okay, so today we're going to talk about slopes and what slopes are. Slopes are rise over run, which if you want to know what rise means, it means it's like height over its length. And that should make some sense because if you think about like a mountain, where we have the word like slope kind of comes from in nature, when you talk about how steep something is, you talk about like how high it is compared to how long it is. So something's like really, really tall and doesn't have much length. This thing has a really steep slope compared to if this thing has a really long length and a really small height. It's not as steep. It's pretty shallow, and it still goes down, but it doesn't go down as much. So the idea of slope is this rise over run. And so we're going to start to try to make basically pictures of triangles on a graph. So let's look at an example. Here's a picture of a line, and I want to find the line slope, and I found 2 points. Now there's lots of points that happen anywhere that you have a cross section on a box. There's a point, so we could actually have a couple more points in here. There's one there and one there. And so if I want to find the slope, I'm going to try to draw a triangle that finishes this section. So you can see that I go down and over. So I go down 1 and over 3. So my slope, I have a rise of -1 because I went down. And I went right 3, so that would be a +3. So my slope would be -1/3. And you can see between any points, it's the same thing. 1, 3. 1, 3. So slope is basically this idea of multiple triangles being completed. Let's take a look at another example. Okay, again in this second example, we're going to try to draw a triangle from like this point to this point. And this time you can see I need to go up and then over. So I'd go up 1, 2, 3, and over 1. And since I'm going up, that would be a +3. And again, I go to the right 1, so that would just be a +1. So my slope would be 3/1. Let's look at one more example from a graph. Okay, and again in this last example, I want to find the triangle that goes from there to there. So I'd go over and then up. So this time we can see that I go left 2, so that would be a -2. And up 1, 2, 3. If you ever have a fraction like this, it's actually really bad to have this negative sign on the bottom. So we don't want that. It means the exact same thing if I just move the negative sign to the top. Because you can see that we could have gone down 3 and right 2. So it doesn't matter whether the negative sign's on the bottom or the top. But for us, when we're writing these things in, we really need to shift all these negative signs from the bottom to the top because it's hard to think about things that have negative parts to the whole. Okay, let's look at some non-graph examples. So if they give us some points and we have to figure out what the slope is. Okay, so in this example, we're going to do the same thing to figure out the slope. And again, the slope is this distance of like up and over. So I have my overs in this case are my x values, which are the first points, and my ups in this case are my y values. So generally we want to just think about how we get from one point to the next. And we can do this by taking these points and kind of graphing about where they are. So I'm going to draw my coordinate axis. This one's over at -7 and up at 14, so it's right about there. And this one is over 8 and at 10, so right about here. Okay, and I'm just sketching these. They're just general, like a generalization. And then I think about how much down I have to go. Well, if I'm starting up at 14 right here, and this is at 10, to go from 14 to 10, I'd have to go down 4. And then I'm all the way here at -7, and I have to go over to 8. So I was at -7, and I got to go all the way over to 8. So if I think about a number line, at -7, 8's right here, 0's kind of in the middle. I have to go 7 to get back to 0, and another 8, which means I would go 15. So again, it's the same kind of thing. I'd have -4 over 15. And that would be my slope. Let's try a second example from here. Okay, we're going to do the same thing. Again, when I think about slopes, I think about the graph. So when I think about this graph, I go, okay, this is over at -20 and down -4. So I have a dot right about there. And then my next dot is over -12 and down -10. So about right there. So we're going to draw this again. So I was up here at -4, and I had to go further down to 10. So if you're at -4, and you have to go to -10, that would be 6 units. So let me get rid of that, and get rid of this. But I would have had to go down 6 units. So there's my height. Then I have to think about over. So I was at -20 here, and I have to go over to -12. Well, that should be a distance of 8. If you count it over. So like 19, 18, 17, 16, 15, 14, 13, 12. If you kept tallying as I went, you would have tallied 8 marks for all the distance. So again, my slope is this. Now I'm not going to leave my slope this way though, because this fraction isn't simplified. So if I wanted to simplify this fraction, I could divide the top and bottom by 2, which would give me -3/4, and that would be my slope. For slopes, we always want to leave it in the best simplified form because we just want to be all on the same page when we're talking about things so that people don't go, oh, -6/8 is different than -3/4. No, it's the same answer. We just simplify them to make everything nice and easier. So that's how you find slopes. There's one more different way that you might see this. There's a formula to find slopes instead of just approximating where it is that will give you the same thing. We'll try it with this one. So the formula that you could have is y2 minus y1 over x2 minus x1. And this is how it works. I'm just going to call this x1 and this x2. And this one y1 and this one y2. Okay. So then we just kind of plug stuff in. So that would be -10 minus a -20. Whoops. -4. Can't write that because it would be y2 minus y1, and y1 is -4. Over -12 minus a -20. When I solve this, I would find that -10 minus a -4, well, that's a positive, so it'd be -6 over, again, same thing's going to happen down here when you have two negatives in a row, positive, over 8. And just like last time, that reduces to -3/4. This is a more formulaic way of doing this in case you don't want to draw the graph and approximate where these dots are and then start trying to draw your triangle. So if you want to use the formula, again, I'm going to write it a little bit nicer in this other space that I have. But if you want to use this to find slope for lines, this is only in slope for lines, you can use y1 or y2 minus y1 over x2 minus x1. And that's kind of how you can find the slope between 2 points. And it will give you the same thing as if you approximate. So, try the different examples, and if you get stuck on anything, please ask questions. Thanks.